Okay, good morning, grade 11s. Good morning, the rest of the grade 11s. Okay, let's quickly mark. You had to complete Theorem 9's exercises or examples. So, can anyone please help me with the size of x and for what reason? Yes, Kumo? X is equals to 72, and then your reason will be tan chord. Alright, y 65 degrees, and the reason is also tan chord. Alright, example 2. I showed you yesterday before you guys left that that 50 degrees is the angle between TBE. And then the 75 degrees is TBF. So the one we're starting with is the angle X. Can anyone please tell me what is the size of angle X? 55. Why? Well done. So the chord subtending X is BD, and the angle it makes with the tangent. Your classmates. The tangent there is making an angle with that chord, and that's 55. So you all see it. You're not struggling to see the tan chord. Good, good. Okay, the next one is Y. Who can tell me what is the size of Y? 50. Baie mooi. And the same reason, eh? Tan chord, because the chord that subtends Y is BE, and then BE makes an angle with the tangent of 50 degrees. Next one, Z. What is Z? What do you, what do you say? 105. Did you first find M? Okay, let me just write M first, sorry. What is M? Y? Also tan chord. Because the chord that subtends it is BF, and BF makes an angle with the tangent 75 degrees. Okay, Y, what did you say Z is? 105. Y? Well done, grade 11s. Do you all understand? Yes. Sure. Are you seeing them? Okay, good job. How did it go with example 3? Good. Fine, eh? It's not that bad. Okay. Let's look. The first one we want to find is x. Oh, there are two. We want to find x and we want to find y. So remember, you don't always, or sometimes you're going to have to find another angle that wasn't asked. No. Okay. So what did you guys do to find x at example 3? Moana. Which one is it? Okay, that one, B1 there. Okay, so I just want to say very quickly, it's perfect what you did. But now, when we're in grade 11, we don't really name the angles that weren't asked. So you have to learn to name it correctly with the points here. So you would name that one D, B, T, or B1. Do you understand? Okay, so is it fine if I call it B1? You know which one I'm referring to. Right, angle B1 is what? Y? Well done. Do you all see B1 is 54 because of tan chord? Okay, and then how did you use 54? Which one? X now. Okay. So you saw that x will also be 54 because of tan chord, because that chord is also subtending x, the one that's BD. And BF is subtending the 54. So the same tan chord angle created there is being reflected in the other segment, in the small circle and in the big circle. Do you all understand that? Did you see it? Yes, okay, good job. Why? How did you find y? Angles on a straight line. Did you go and find D1 first? D1 first. Okay, so there are many different ways that you can find y. What did you say, 92? Okay, let me just show you. You found this one to be 54. Ne? So you could have also found that angle, and then there's a tan chord for that one, or you could have done the sum of the interior angles and then the angles on a straight line, any way that you wanted to do that. Okay, do you understand? You could also have found that one and then you've got just the quadrilateral, not a cyclic quad, and take it much further. But the shortest way would be to find D1 with the sum of the triangle. What was D1? 88. Then it would be sum of triangle, and then it would be adjacent angles on a straight line. Now, do you remember that I said if you see you get these two after each other, you've missed something? Do you remember that? The two things I said was, if you have sum of a triangle and then angles on a straight line, two reasons after after each other, then you missed something. And the thing that you missed, and I just want to show you, you would get all your marks for this, but very important, look for it, notice it. Y is the exterior angle of this triangle, so you could have just said y is equal to x plus 35. Do you understand that? You see it. Look for the exterior angle of a triangle. Okay, are you all good with that? Okay, are you done writing? Everyone? Okay. So listen to me. You have to know the 9 theorems very well. We divided it into 3 groups. Who can tell me, put up your hands and then you tell me what are the 3 midpoint theorems? Which 3 theorems can we use when we see we have a midpoint? Kuma. Angle at the center, 2 times angle at the circumference. Yes, that's one. Angle in a semicircle. Good job. That one is that one we get from angle at the center, angle at the circumference. Eh? And what is the third one? The line from the center. If it's given that it's perpendicular, you use the theorem to say that the chord is being bisected. If they say that the line from the center is bisecting the chord, then you use the theorem to say that the angle is 90 degrees. 3 theorems for midpoint. Then we have 3 cyclic quad theorems. You can tell me the 3 cyclic quad theorems. Angle in the same circle segment. You remember that one? No? When it's subtended by the same chord, then those angles will be equal. Which one as well? Second one. the exterior angle of the cyclic quad is equal to the opposite interior angle. And then the third one, opposite angles of a cyclic quad are supplementary, not equal, no, supplementary. Right, 3 tangent theorems. Okay, I heard tan chord in that. Okay, you all know tan chord. The angle between the tangent and the chord will be equal to the angle that the chord subtends in the opposite segment. Eh? Not at the same side as the angle that's all on the tangent side. Right, second one. The radius and the tangent will always be perpendicular. So you've got the 90 degree there. And then the third one, tangents from the same point. They are equal to each other. And remember, when they are joined in the circle, that means there's an isosceles triangle. Okay. I want you to quickly take out your textbooks for me, asseblief. And your workbooks. And you open your textbook on page 230. Okay. I want you to look here on the board. This is question 2A on page 230. So, I want you to understand that if they give you a diagram like this, but they don't say that PT is a tangent, then you cannot assume it's a tangent. Eh? It must be specifically given that it's a tangent. So what they're asking at this question is they're asking you to prove that. So we know it is going to be. Prove that PT is a tangent to this circle. Okay, so listen to me. You can't say, right, this angle is 60, that angle is going to be 60 because of tan chord. This is, you cannot use tangent. You have to prove that it is a tangent. Do you understand what I'm saying? Okay. So we have to try to find a different way to prove that this is a tangent. So this one is so easy because they have given it to you that angle C is 120 degrees. Okay? So you don't even have to copy this. I just want you to understand the way that we will write it. You are going to try B yourself. Then you're going to write it yourself. So I'm going to say C is equal to 120 degrees. Then I say it was given. Okay? So if I want to use something that they've given me and I write it down, then you have to say it was given. Okay? Right. C is 120, it's given. C1 is equal to C2. That was also given. né? So because they are equal to each other and they are equal to 120 together, I can I can come to the conclusion that C1 is equal to C2 is equal to 60 degrees. There's no geometrical reason for that. If two things are equal and they add up to 120, they must be 60 each. Does that make sense? So that means that this angle is 60 degrees and that angle is 60 degrees. Now, if this line is in fact a tangent, that would mean that this angle, which is 60, and I'm using this one because I've got information on it. Okay? I'm not going to use that angle, I have no information. This angle here is subtended by the chord PA. Ne? And PA makes an angle with PT. That is also 60 degrees. So do you agree with me that this must be a tangent? Because the angle between the chord and line PT, you cannot say and tangent PT. Ne? Not a tangent, I want to prove it's a tangent. The angle between AP, or the chord, and PT is 60. And it's also the angle that is being subtended by AP in the opposite segment is also 60. So because the tan chord angles are equal to each other, I can say that that line is a tangent. Does that make sense? Okay, so I'm going to say thus, PT is a tangent, and then I don't give the reason tan chord. I explain that the tan chord theory is true. So I need to understand what the tan chord theory says, because that's what I'm going to have to explain. The angle between chord AP is equal, not easy, AP and PT is equal to the angle that AP subtends. Do you see I didn't say tan chord? Not once. Because it isn't a tangent, I have to prove it's a tangent. So you cannot use it as a tangent. Do you understand that? Okay. Alright, we are going to start slowly. Just get into solving unknown angles. So you must remember all 9 theories and all the geometry that you've done up until today is fair game. That includes triangles, adjacent angles on a straight line, vertically opposite angles, parallel lines, fun functions. If there's parallel lines, the fun functions will be there. Everything that you have learned can be used in these questions. So this activity that we're going to do, exercise 10, is, I'm just going to put it here on the board so you can see. This is the activity after you would have done theorem 9. So most of it, theorem 9 is tan chord. Okay, so there's going to be a lot of tan chord in these questions. Okay, but there's going to be other things as well. So I need you to look for everything. Remember, for example, if you look at this question I, is there a center? So you don't even look for the first 3 theorems. Is there a cyclic quad? No. So you don't look for them. All you have here is 2 tangents, and obviously you've got chords and a triangle. Are those two lines equal to each other? Why? No, these two. They aren't equal to each other. If it's not given and you can't prove it, you can't use it. Ne? It might happen that they might be equal in the end, but you cannot use something like that. So don't let it fool you. Sometimes learners call that a radius. It's not a radius, ne? It's a chord. It's just a normal chord. Okay. So there you can't use the first 6 theorems. Don't go and look for them. At H, there's no center. You don't use the first 3. But do you see there are equal chords, ne? Okay, so there we know we might have a tan chord, cyclic quad. And do you remember I said we just need 4 points on the circumference, then it is a cyclic quad. Here, if I look at K, look at this one. Is there a center? Yes, so the first 3 is fair game. Okay? But you can also already see that the line from the center is not perpendicular or bisecting any chord. So that theorem 1 doesn't feature a lot in a combination. But if you mustn't just leave it out, ne? Okay. Is there a cyclic quad in K? Yes, there are 4 points on the circumference. Then there's a cyclic quad. It doesn't have to be closed. Okay. Is there a tangent? Yes. So all of our theorems might be fair game. But if I think about the cyclic quad theorem, it has to be close to have an opposite angle. Do you agree? So that one is out. It has to have or one of the sides has to be extended to have an exterior angle. Is there any extension? No. So do you see where you had 9 theorems, you can very quickly, streamline the number of theorems that might be possible there. And that makes it easier. So cancel the ones that can't be in there. Don't think about them. Think about the ones that you can use. Okay, at L, once again, there's a cyclic quad. Do you see it? It's closed. So I can look for opposite angles. There's no crisscross. The crisscross in the cyclic quad means angles in the same circle segment. No, but you see there's no crisscross. So that one is actually out. There's no exterior angle created. That one is out. Even though there's a center, it's not on any chord. No? So that one is out. There is no angle created or subtended in the center. Do you see? But there is a diameter. And what does the diameter mean? Angle in a semicircle. There's a straight line. Remember, don't forget when the radius meets the tangent. That's one of the theorems. But there's only one tangent. So tangents from the same point is out. You can't use it. Okay, so you understand how you're going to go to work with it. So you're going to do for me, and please, grade 11s, just draw them over, but roughly. You don't have to now use a pacer and then measure and what to get it perfect. I'm going to give you papers in any case on Monday when everything is thrown together. So you will have those sketches with you. Okay, but draw them over in your workbooks. So you're going to do for me question D, E, F, G, I, J, K, L, and number 2B. So you're going to use the time now in class. You're going to do it now. If, for example, you look at E, and you can immediately give the answer of X and Y, then it's not necessary to draw it over. But if you see you need to play with it a bit, you're struggling to get one, then you draw it over, you do it, okay? Remember, everything you say must be accompanied with a reason. Okay? And if it's not given and you can't prove it, you cannot use it. Those pages you can paste in. You must keep it when you study for a test that has geometry. I'm just quickly going to stop the video.